Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 16 of a unit electrostatic potential and capacitance. Today we are going to discuss about the RC circuit. Basically RC, this stands for this is resistor and this is capacitor. So it's a resistor capacitor circuit. This is RC circuit. Basically, it is an additional topic, but certain kind of transient analysis. Transient, when I mean transient, I mean it's an varying with time, and certain steady state analysis has been asked in certain JEE examinations, as well as by at one or two times by AIPMT examinations as well. Yes, so when no NEET were there and AIPMT were there, yes, AIPMT has asked certain questions from here. So we are going to see this. Yes, so let's begin then from today. It's an RC circuit. First, it's a first thing, it's a charging of capacitor. What we are supposed to do is that we have a battery here and the supply has been provided to the batteries of E. We have a capacitor here and the capacitance of a capacitor, capacitance of the capacitor is C, and we have a resistor over here. I'm sure you must have studied the resistor and the basics of resistors. That means what resistor is all about and how does it behave when they are connected in series, when they are connected in parallel, and all that basic stuffs you must have learned in the class 10th. Yes, we are again going to advance, we are again going to study the same in class 12 also in the third unit, but you know the basics. Yes, so this is resistor R and this is switch. When I say switch, I say generally two states. One switch is open, that means circuit is not connected, and one when the circuit is connected, which is switch is closed. At this initial state, switch is open, and then I am going to about to close it. That means at t is equals to 0, I am going to close the switch. So according to the Kirchhoff's law, I understand that at this point of time you don't know what the Kirchhoff's law is all about, but we are going to focus on the formula only. So you just look through it, you just go through this, and we are going to again revise this once you have been done with the third unit, that is of current electricity. So just go through this. It's an according to the Kirchhoff's law, that is E minus IR minus VC equals to 0. I know that I is equals to dq by dt, that you know, charge divided by time. So this is equals to E minus R. For I replace dq by dt, and for Vc minus of q by c, that you know. So now I am going to rearranging the things like dq divided by c minus q is equals to dt by rc. So let's integrate this both the functions. This from charge 0 to charge q, and this from time 0 to time t. So if I integrate this, I require this, and I'm going to have this. This is q of t, that means charge at any time t can be given as c into e into bracket 1 minus e to the power minus of t divided by r into c. This is required, and you are going to remember this thing only. Yes, if I integrate this, that means I is equals to dq by dt. If I integrate this, this is d by dt of q naught into bracket 1 minus e to the power minus of t by cr. I am going to have this. This is I naught into e to the power minus of t divided by cr. Yes, I hope this is clear. Is it? Is it clear? Are you sure? So, so what we are going to study, and we are going to discuss the two situations, one for the charge, another for the current. So before we begin our study, let's understand that my charge was given as q is equals to ce into bracket 1 minus e to the power of minus of t divided by r into c. This was the relation. Now what is the value of time? let's say I'm going to study this at t is equals to 0. I'm going to study this at t is equals to 0. What would be the situation? That I can write like this. It is a q is equals to ce into bracket 1 minus e to the power 0. This is q is equals to ce into e to the power 0. And when any number having a power of 0, that number will give me an 1 only. So it's a ce into 1 minus 1. This is c into e multiplied by 0, which comes to 1 0. So at t is equals to 0, my charge will be a 0. Now let's look at the charge value when time is infinite. So let's have this q is equals to ce into bracket 1 minus e to the power minus of t by rc. This is my master formula. And if I replace the time with infinite, what I am having is this is q is equals to ce into bracket 1 minus of this whole term would become a 0 if I replace t with infinite. So this is 1 minus 0, and so it becomes q is equals to ce into 1, which will give me a c into a, this is charged q. Yes, so at t is equals to 0, it is a 0 charge. At t is equals to infinite, it is at a ce charge. Yes, now at at t is equals to rc, this is what we know as the time constant. It's in multiplication of r and c. It's in multiplication of r and c. This is time constant. So my master formula was q is equals to ce into bracket 1 minus e to the power minus of t divided by rc. Let's replace the value of t is equals to rc. Then it will become q is equals to ce into bracket 1 minus e to the power minus of 1. So this will be ce into bracket 1 minus 1 by e. And when I say it's in 1 minus 1 by e, that will become 0.63. This 1 minus 1e, it's a 0.63 of c into e. Even if you wish, you can write like this. It's a 0.63 of q naught. Here I'm mentioning that q naught is equals to c into e. So this would be the situation. I hope these things are clear to you. Is it? Is it? Is it clear? Are you sure? Great. Now, one more thing. I I is equals to I naught into e to the power minus of t by rc. Now let's study this at this 3 time as well. First, at t is equals to 0, what would be the situation? I is equals to I naught into e to the power 0. And when I say e to the power 0, that means it's an I naught into 1. And when I say I naught, I mean e naught by r. Now, at one more instant, at t is equals to infinite. So, it's an I is equals to I naught into e to the power infinite. Technically, it is a minus of infinite divided by rc. So, this total term will be a 0, and anything that has been multiplied by 0 will give me a 0. And last but not the least, it's a t is equals to r into c. So when I say t is equals to r into c, this will give me be I is equals to I naught into e to the power minus of rc divided by rc. So this is equals to I naught into e to the power of minus 1. And when I say I naught into e to the power of minus 1, it is I naught into 1 by e. This will be 0.368. Please remember this value. 1 by e, it is a 0.368 of I naught. Yes. I hope these things are clear to you. Is it? Is it clear? Yes. At t is equals to 0 time. At t is equals to 0 time, my current will be E naught by R. And at t is equals to infinite time, my current will be a 0. And at t is equals to RC time, my current will be equals to 0.368, or I can say it's a 36.8 percentage of I naught. I hope those things are clear to you. Yes, this is the situation when capacitor was being charged. It's a charging of capacitor. This is the situation of charging of capacitor. I hope those things are clear. Yes, we are going to coming back at this slide, but before this, let's look at the discharging of a capacitor. Now, what was the situation? The situation was one capacitor was there initially. Initially, the situations look like this. It's a one capacitor was there. It has been connected with the battery and switch has been closed at t is equals to 0. Now, charge would be started flowing on this, maybe from this to this. Yes, and the capacitor starts being charged. Let's say this is the positive plate and the opposite plate is of negatively charged, and by the time ends, by the time passes, the capacitor has been fully charged. Now once it is fully charged, let's just now we are going to open the switch, and when we are going to just disconnected open the switch and then disconnected from the battery, now we are connecting the capacitor with resistor R. That means capacitor behave as a battery because it has been charged, and when it has been charged it is having a potential difference of, let's say, I or let's say V. So now at this point of time, again for a momentarily, capacitor behaves as a battery to a resistor R. So the situation will be, I know that V is equals to IR, and this V can be given as Q by C is equals to minus of R into dQ by dt. So if I integrate this, it's a dQ by Q is equals to minus of dt by RC. This charge will be going to be integrated from charge, initial charge Q naught to final charge Q, and time will be when charge Q naught it's a time 0, when charge Q it's a time t. If I integrate this, what I'm having is it's a Q of t is equals to Q naught into e to the power minus of t divided by RC. Yes, yes, please remember this. And if I differentiate this so that I can have a current, it is I is equals to minus of dq by dt, and it is this formula that I get the same, I naught into e to the power minus of t by cr. Yes, so when we already discuss the time boundage of this relations, I is equals to I naught into e to the power minus of t by cr at t is equals to 0 and at t is equals to infinite and at t is equals to rc. But let's discuss the time study of this relation q of t. It's a q of t is equals to q naught into e to the power minus of t divided by rc. So when I discuss this at t is equals to 0, what would be the situation? Now you must know this. It's a q naught into e to the power t to the power 0. This is q naught, and q naught, that means c into e. Now at t is equals to infinite, what would be the situation? The situation should be q of t is equals to q naught into e to the power minus of infinite by rc. This is equals to q naught, this is equals to q naught into 0, and when it's a q naught into 0, it's a 0. One more time, it's a t is equals to r into c. So this is equals to q is equals to q naught into e to the power minus of 1, and when I say minus of 1, it is a q naught multiplied by 1 by e. So this will be a 0.368 of q naught. Now we know 1 by e, it's a 0.368. I hope those things are clear. Is it clear? So let's now discuss the summary of the situation. When we charge the capacitor, basically this is a charging of capacitor. The relation is Q is equals to C into E into bracket 1 minus e to the power minus of t by RC. So at t is equals to 0, at t is equals to 0, charge would be a 0. At t is equals to infinite, the charge will be of C into E, and at t is equals to RC, the charge would be equals to, the charge will be equals to, it's an 0.632 of C into E. And when we talk about the time, this I is equals to I naught into e to the power minus of t by RC. When we talk at t is equals to 0, then current, this is e to the power 0 would be equals to 1, so I is equals to I naught. At t is equals to infinite, it's an I is equals to 0, and at t is equals to RC, this is equals to I is equals to I naught by E. This must be remembered by you guys. Please remember this. So when I observe this current very carefully, I am having this, that at t is equals to 0, my current is I naught. At t is equals to infinite, my current is 0. And at t is equals to RC, it's in 36.8 percentage. So the things will be that when I write this, I is equals to I naught into e to the power minus of t by RC, at t is equals to 0, this I is equals to I naught. That means now this, remember, capacitor behaves as closed switch. Because when I say I naught, I mean only E naught by R. In the circuit, if you remember the circuit, the situation was something like this. It has been connected with the capacitor. Yes, this is E naught. So when it's a t is equals to 0, that means when switch has been just closed, this is I is equals to I naught, which is E naught by R. That means capacitor has been removed and this has been connected, this wire has been connected. So this is the situation when t is equals to 0. Now one more instant, at t is equals to infinite, I know that I is equals to 0. So when I is equals to 0, what I can consider at t is equals to infinite, I equals to 0. That means this has been disconnected. From here. So that means capacitor behaves as open switch. So I hope these things are clear. So at t is equals to 0, capacitor behaves as closed switch, and the current will be equals to I naught is equals to E naught by R. And at t is equals to infinite, current would be equals to 0. When we say t is equals to 0, sometimes they say just after switch is closed. When they say at t is equals to 0, that means they say that just after switch is closed. And when they want to say at t is equals to infinite, they say after a long time. Even one more option, they say at a steady state. This all means that we need to consider this at t is equals to infinite. I hope those things are clear. Is it? Is it clear? Is it? So please remember this. At t is equals to 0, capacitors behaves as a closed switch. That means you are going to remove the capacitor and just connect the wire. And at t is equals to infinite, capacitor behaves as the open switch. And when I say open switch, just disconnect the capacitor and do not connect anything. Yes. So ready for the numerical? Let's begin then. Suppose the question is, it's a capacitor, and in parallel to that, one of the resistance has been attached, R2. So this is the circuit, and here one of the switch is connected. What they want is that find out current at first t is equals to 0 and second at t is equals to infinite. You want to find out the current at this two instant, at t is equals to 0 and at t is equals to infinite. So let's begin then. First, at t is equals to 0, what would be the situation? I know that when t is equals to 0, my should behave capacitor behaves as closed switch. So when I redraw the diagram, the situation would be, this is the battery, this is the R1, capacitor has been connected with the wire, this is the R2, and this has been connected. So when current is started going from this, it will move in this. Now here it will be having a two path, and as this is path having no resistance, it will choose this. So it cannot go through R2. So when I write the current, I should write it as I is equals to E divided by R1. I hope these things are clear. Is it? Is it clear? Is it clear? Yes, good. So this is I is equals to current is equals to E by R1. I hope these things are clear. And now at second, at t is equals to infinite. So I know that at infinite, capacitor behaves as open switch. At t is equals to infinite, capacitor behaves as open switch. And when I say it's an open switch, I mean you need to just remove the capacitor and do not need to connect anything. So my diagram should look like something like this. This is the situation. This is the R1. Here the capacitor was there. Now it has been disconnected, and here it is the another resistance which is of R2. Yes, this is the situation at t is equals to infinite. So when I say at t is equals to infinite, current will be started moving from from here. Now it's an open path, so it is not going to move through this. It's moving from this, and thus circuit has been completed. Yes, so the current I naught can be written as E naught divided by the total resistance, and these two are connected in series. So what I can write, it's an I naught is equals to E naught divided by R1 plus R2. Is it clear? Is it clear? So will you be able to do this kind of questions? Are you? Is it easy? Yes. Can you do this? Okay, let's begin then. Now you are going to solve this completely. The next question. The situation is something like this. Battery. Here the switch will be there, and one more resistance will be here. Here the switch, it's an 10-volt battery. This is the resistance of 5 ohm. This is the resistance of 5 ohm. This is the capacitor. And what we require? We require find current at first t is equals to 0, and second t is equals to infinite. This is the situation, and this is our requirement, that I need to find out the current at t is equals to 0 and t is equals to infinite. Now start doing it in your book. Keep it fast. So what would be the situation in the first? At t is equals to 0, that means at t is equals to 0, how capacitor behaves? Capacitor behaves as a, what is it? Yes, it's a closed switch. So when it is a closed switch, the current should be is equals to 10 volt divided by, moving from this only, this is 5, and as it has been connected with this, yes, it is moving through this only, so this 5 ohm resistance has been bypassed. So this is 10 divided by 5, it's a 2 ampere. And and when I say at t is equals to infinite, it's an open switch case. So when I say open switch, this is simply disconnected, and when it is disconnected, current will be moving through this, and the situation would look like this. This is I is equals to 10 divided by 5 plus 5, so this is equals to 10 by 10, which will be an 1 ampere current. I hope these things are clear. Is it clear? Is it clear? Yes. So can you do this? Great. Now let's move to the next concept. It's an calculation of RC, time constant. If I need to find out the time constant of the circuit, how should I do this? Yes, but before we go through it, first I need to remember the steps, that what should be done. First, I need to short all the voltage sources. Second, find the equivalent resistance across the terminals of a capacitor. And the third, it's a time constant, which would be tau is equals to R equivalent multiplied by C. These are the steps. So when I have been asked to find out the time constant of a given circuit, it's an calculation of time constant, then first thing I need to do is that I need to short all the voltage sources. That means when I say it's in short all the voltage sources, then I must understand that remove the voltage source, remove the voltage source, and connect wire at that place. Yes, I just need to remove the voltage source and connect wire at that place. Next, the next task would be to find out the equivalent resistance across the terminals of a capacitor, that you can do. And the third task would be to find out the time constant. It's a tau is equals to R equivalent into C. Yes, can you do this? Let's have a look. The question is something like this. One of the resistor is there, and the resistor is of 3R. Here battery is there, it's a battery of E. The another resistor is of 6R. Here one of the resistance, it's an R, and here capacitor is there. So situation is something like this. And what they ask that find the time constant of the circuit. Yes, this is their requirement, find out the time constant of the circuit. So what I need to do, I need to just follow the steps. First is the short all the sources, that means short the battery. Now if I short the battery, the situation would be something like this. It's a 3R resistance. Here battery was there, now I have replaced with the wire. It's a 6R. This is R, and this was the capacitor. Yes, this was the situation. Now second is to calculate R equivalent across the capacitor. So when I calculate the R equivalent, I just open this and I'm going to calculate this from here. It's an, let's say, resistance of RAB. So in 10th class we have learned this, that this 3R and this 6R is in parallel, and the equivalent of this has been connected with this resistance in a series. So my R equivalent should be 3R and 6R in parallel. So it's a 3R into 6R divided by 3R plus 6R plus R. So it's a 3 6 are 18 divided by 9. It's a 2R plus R. This is 3R. This is the second step. And the third step, it's a tau is equals to R equivalent multiplied by C. It's a 3R multiplied by value of an capacitor. It's a 3R into C. That's it. You did it. Great job. Is it clear? Is it clear? So can you do this? Can you do this? Let's have a look. Next question. Suppose the situation seems something like this. It's an E. Battery is there. R. Let's say this is R1. Let's say this is R2. And the capacitor has been connected over here. It's a capacitor. So again same question. It's a find out time constant of the circuit, of the given circuit. So now let's move on quickly. First, what was first step? It's a short all the battery sources. So when I short all the battery sources, a thing with something like this, it's an wire. Here a resistance R1 was there, here resistance R2 was there, and here the capacitor was there. This is the situation. Now on a second step, on a second step, find R equivalent. So when I say find R equivalent, I need to just remove this. Yes, and I need to find out the equivalent from this point, this terminal. So when I say R equivalent, I can observe this very carefully, that when my current reaches to this point, it is having an alternating path having low resistance. So it is not going to move from this, and it is just going to bypass this R1, and it is going to move through this. So my R equivalent would be equals to R2 alone. What was your answer of R equivalent? Is it same? Is it? Great job. Next, third point. It's an tau is equals to R into C. So this is R2 multiplied by C, and that's it. You did it. Great job. What was your answer? What was your answer? Is it same? Is it? So can you do this kind of questions? Will you be able to do this kind of questions? Are you sure? Are you sure? Can it be done? So ready to move for the next questions? Let's begin then. A battery is there. Here the resistance, it's an R2. Here the resistance, it's an R1. Here the resistance, it's an, let's say, R3. And capacitor, find RC, time constant of the circuit. This is the requirement, find RC, time constant of the circuit. So how can you do this? How can you do this? It's a C. So what I need to do is, let's begin with the first step. That means short all the batteries. So when I short this, the situation should something like this. It's an R2. Now this is R1. This is R3, and here a capacitor is there. This is the capacitor. Now on a second step, find R equivalent. So when I find R equivalent, I need to just remove the capacitor, and I need to look at this two terminals to find out the R equivalent. So what would be the situation? This and this two are in parallel. So, and parallel of this combination has been connected with the series in this. So it's an R1 into R2 divided by R1 plus R2 plus R3. This is the R equivalent. And now it's a time for the next step. It's a tau is equals to R equivalent multiplied by capacitance C. So this is equals to R1 R2 divided by R1 plus R2 plus R3 multiplied by C. That's it. Yes. Yes. So can you do this? Can you do this? Are you sure? Can it be done? So let's do the last question of this topic. It's an RC circuit. So the situation is something like this. A battery is there, and resistance is there, which is of R1. Another resistance, it is of R2, and the capacitor is there. And here we have connected one of the switch. This is capacitor, and one more resistance is there, which is the R3. So what they want find out current through circuit at first t is equals to 0, second t is equals to infinite. Find out current through the circuit first at t is equals to 0 and second at t is equals to infinite. You need to find this. So how can you do this? How can it be done? So what I'm supposed to do is at t is equals to 0, capacitor behaves as. Now tell me what would be the situation. At t is equals to 0, what would be the situation? At t is equals to 0, capacitor behaves as closed switch. Yes, and when it behaves as a closed switch, it has been connected like this. When switch has been connected, yes. So current should be I is equals to, it is moving from here, this and this two are in parallel, so this is I is equals to E divide by equivalent of this, it's in R2 R3 divide by R2 plus R3, and combination of this is in series with this, so plus R1. This is the final answer at t is equals to 0. Now what would be the situation? What should be the situation at t is equals to infinite? At t is equals to infinite, capacitor behaves as open switch. That means no current should pass through a branch where capacitor is connected, or I can write like this. So my current will be equal to, my current will be equals to, as no current can pass through the R2, it is just the E divided by R1 plus R3. I hope these things are clear. Is it? Is it clear? Okay, great then. So let's wind up this lecture here. Yes, this is all about the RC circuit. You need to just remember the formula. Uh, Maybe none of the time the derivation has been asked, or very rarely even in the board examinations derivation has been asked. So you just need to focus, on the formula, and our things will be done. But question has been asked from this topic, so please do as many questions as possible. Please revise this unit thoroughly, because this is a very very lengthier one unit. Yes, because this is already class number 16, and even we have been left with the two more lectures, lecture number 17 and 18. They are of the previous asked questions. So before you tune to those questions, please revise the unit from very beginning. That means the when we start, it's and what is potential and what is the potential of different units and all those. So please revise this. Also, I request you guys to please revise the first unit, electric charge and field, because these two units have been linked with each other. This is the combination of electrostates. So please revise this. Yes, have a good day. Take care. Bye bye.